Welcome to this module of Professor Messer's free CompTIA Network Plus certification training course, the online training course that keeps you in peak physical condition. I'm James Messer, and this module is all about address formats. Our section 1.3 of N10-004 says that we need to identify the following address formats. We need to know what a MAC address is, we need to know what an IP version 4 address is, and we need to know what an IP version 6 address is. So when we're done with this video today, you'll be able to look at any of those and know instantly exactly what those are. We'll start with MAC addresses. A MAC address stands for Media Access Control. These are OSI Layer 2 addresses. These are really the fundamental addresses that devices use to communicate to each other. They are the physical address of the network interface card inside of your device, whether you're on a computer, whether your physical device is a router, whether it's a firewall, whether it's a server. Every network card has a MAC address on our Ethernet networks. These MAC addresses are 6 bytes long, and they're usually represented in hexadecimal format. We're going to look at some in just a moment. The first 3 bytes, half of the MAC address itself, the first 3, are unique to the manufacturer of the network card. They are assigned by the IEEE. So you should be able to look at the first 3 bytes, which we call an organizationally unique identifier, or an OUI. And those first 3 bytes are something that's very common for the manufacturer. So if you look at those, you can look at the first 3 bytes and say, oh, that card was made by HP, or that card was made by Dell, or that card was made by IBM. You can do a Google search on IEEE OUI, and you'll get the big list, the big index of all of the different manufacturer unique identifiers. The last 3 bytes of the MAC address are usually assigned sequentially from the manufacturer. So these are hardwired. They are burned into the ROM of the network card itself. And ideally, there's not going to be duplications. It's pretty rare to run across a duplication of a MAC address. It does happen, much rarer these days to run into problems with that. But there have been times in the past where I've run across a network where the cards themselves were duplicated. There are ways to manually configure the MAC address of a device, and I've run into situations where someone has by mistake put the same MAC address on 2 different devices. Pretty rare. You don't run into that often, and most of the time you just use the burned in MAC address that's on the network card. Here are some representations of exactly the same MAC address. So you see them written different ways depending on the environment that you're in. There's this Dell and then 6F06F2. There's this 002170 6F06F2, and then 002170 6F06F2 separated with these dashes rather than the colons. Notice that here is the Dell. We just put the 002170 is the organizationally unique identifier for Dell. So sometimes you'll just see the application you're using just abbreviates for you and puts Dell right there and says this is a Dell card that has the address 6F06F2. Very simple to follow that. As I mentioned, you can locally assign these. Not usually, though. You usually don't even want to bother doing that unless there's a very, very, very good reason to do so. If you'd like to see what your MAC address is, you can go out to a DOS prompt on your command prompt on your Windows machine and type ipconfig/all. You may need to pipe it to more just so you can fit it on the screen. You may have a lot of different adapter cards. It'll scroll off the screen, but you'll normally see a description of it. And here is my Dell MAC address, 002170 6F06F2. So that physical address is referring to the MAC address of that network card. Just that simple to figure out where that is. Let's move up the stack 1 to the internet layer where we have IP addresses, and this, more specifically on this slide, the IP version 4 addresses. That's our Internet Protocol version 4. It's this OSI layer 3 address, and we usually see it abbreviated in this decimal notation, this dotted decimal, 192.168.1.131. And when we see it written that way, that's something us human beings can understand because it's decimal, there's periods, it's very well laid out. Behind the scenes, though, your computer sees this as these 8 bits, dot 8 bits, dot 8 bits, dot 8 bits. And very often behind the scenes, you see this referred to as one of those particular sections is 8 bits long. 8 bits, of course, is the same as being 1 byte long. And it is indeed the same on our Intel-based machines as being 1 octet. There are 8 different bits in there. So you may hear these referred to as the 3rd octet of the IP address is 1, 000000001. That is very common to hear that written that way. So altogether, this is a 32-bit address that is also 4 bytes long or 4 octets long. Now, the idea behind this, of course, is if there's only 8 bits that you can choose from, if you turn on all of those bits to 1, the largest number that you can have in any section of this is 255. So you can't have 256 in here. There's not a bits here that would allow you to put the number 256 in there. So the biggest number you could possibly have is 255.255.255.255, or all ones is what we actually call that particular number. And that's why when we look at this from a human being perspective, much simpler to have the dotted decimal, isn't it? Rather than to speak in ones and zeros the entire time for a single address, but behind the scenes, that's exactly how your computer is using it. Of course, the latest generation of IP addressing is IPv6. Internet Protocol version 6 is also layer 3 address. This is where we're moving from our IPv4, and slowly our industry is moving into IPv6, and that's because of a number of advantages. Primary advantage is that we can fit so many more addresses into an IPv6 addressing scheme, and that's because, well, you can see it visually on the screen. Instead of having a 32-bit address, you now have a 128-bit address. It is 16 bytes long, and we usually represent this in 16-bit chunks. And because 16-bit chunks doesn't work very well from a dotted decimal notation, what we've decided to do is represent this as these hexadecimal groupings. So FE80 colon 000 colon. So you can see we're separating them out not with dots, but with colons between those. So before you have 192.168.1.7, now you have this long address, which is much, much bigger than what we have with IPv4. So there's a little more complexity involved with an IPv6 address. If there are zeros in between, like in this very long IPv6 address, you've got a big section here where there's nothing but zeros. That's pretty common. So one of the things that you can do is simplify this by simply putting 2 colons in place where the zeros happen to be. You can only do this once on an IPv6 address, but when you do that, notice that it simplifies things greatly. If there is a 0 at the very beginning of a particular set of hexadecimal numbers, you can drop the 0. So 0652 just turns into 652. That also can help simplify things when you're writing out some of these long IPv6 addresses. Now, whenever you're planning to move to IPv6, you have to have an entire infrastructure of devices that understands IPv6. You have to have routers that work with IPv6. The latest versions of Windows Vista, and Windows 7 work IPv6 right out of the box. A very important one, of course, is going to be your domain name services. You're still going to need to type in the name of a server on your network. You're not going to be able to type in 192.168.2.1 any longer. You're not even going to really be able to remember all of the different IPv6 addresses and typing them in. So your DNS server becomes extremely important to you so that you can simply type in a name and have it figure out all of this IPv6 stuff behind the scenes automatically for you. You don't have to remember any of these very specific IPv6 addresses. Let's see what we've learned in this particular module in address formats. Our first question is, what kind of address is this? 177.0.25.253. Well, it looks very similar, of course, to an IPv4 address. Indeed it is. Our next question, how many bytes are in a MAC address? Well, if we add 3 bytes for our organizationally unique identifier and 3 bytes for the actual part of the address for the device, well, that counts up to 6 bytes, of course. And there's a good example of all 6 bytes written out individually in a MAC address. And our last question, is this a valid IPv4 address? Oh, we have 2 questions left. Is this a valid IPv4 address? 192.1.325.12? No, it isn't, because 325 is well over that maximum number of 255 that we might have in an octet. Still, it's got 4 dotted decimals here. It's just that decimal number a little bit too high for the number of bits available in that particular octet. And lastly, is this a valid IPv6 address? A:/B:/C. Well, it absolutely is. And if you wrote it out, it would actually be 000A:000B:, bunch of zeros, and then 000C. So you can consolidate some of these more complex addresses into much simpler views with IPv6. It's a really good example of taking a lot of those shortcuts, putting them all together to show you A:/B::C. By this point, you should be able now to identify a MAC address, identify an IPv4 address, and identify an IPv6 address and all those different abbreviations that they use. If you'd like to watch any of our other Network Plus videos, participate in our message boards, or send me a message, you can visit our website at freenetworkplus.com.